Hey again, guys. We are now going to go through your final aspect of today's lesson, which is converting from mass to mass. So if you're given the mass of an element, how to convert to the mass of another element. Now, because the chemical equations are written in mole to mole ratios, there is an extra conversion step in this one. But other than that, it's the same concepts that we've been working on. Okay, so I'm going to go through the example on page 361. And hopefully that will help you understand how to finish off the last of your Junopod assignment this morning. Okay, so let's say that we are given ammonium nitrate. Okay, ammonium nitrate is NH4NO3. Ammonium nitrate. And that is a fertilizer, and that produces nitrous oxide gas and water when it decomposes. Okay, so we know that it decomposes to produce nitrous oxide gas and water, liquid. So this is our chemical equation as given to us in the problem. It just says that that ammonium nitrate decomposes, so we know it's a decomposition equation, into nitrous oxide and water. And so now we know that we are given, we are given we're given 25 grams of solid ammonium nitrate, and we want to know the mass of the water produced. Okay, so we are given 25 grams of ammonium nitrate. Now, let's balance the equation first because it is not balanced. So let's count. We've got 2 nitrogens on this side, 2 nitrogens on this side, 4 hydrogens on this side, 2 hydrogens on this side. So we know we need at least a 2 here. 3 oxygens, 1, 2, 3. And now we're good. That's all we needed to do to balance it. Okay, so now we have to convert the grams to moles of ammonium nitrate. Now, this is going to be a little tricky because we do have to calculate the mass of ammonium nitrate, okay? So, in order to calculate our total molar mass of ammonium nitrate, we need the masses of all of our individual chemicals, okay? So, in ammonium nitrate, we have 2 times nitrogen, which is, our mass of nitrogen is going to be 14.1. So nitrogen, 2 times 14.01 is going to give us 28.02. We've got hydrogen. We have 4 of them times 1.01. I'm rounding here. Equals 4.04. And then oxygen, we've got 3 times, again, all round, 16. And that's going to give us 48. To get our total mass, we add all these things together. 28.02 plus 4.04 plus 48 is going to give us the molar mass of 80.04 grams. Okay? So, 80. Again, this is a little bit rounded. So this is our mass of NH4NO3. So now we need to figure out how many moles of NH4NO3 we're given if we're only given 25 grams of it. So we go over here and we convert, okay? So we have 25 grams of NH4NO3. Then we use our conversion factor. Because we have grams now goes on the bottom. 1 mole over what we calculated, 80.04 grams. So we do 25 divided by 80 in this circumstance, and we end up with, where are we? We end up with 0.312 moles of NH4NO3. Okay, so this is what we've ended up with as far as how many moles that we have. So, step 1 was to write the balanced equation. Step 2 was to, if we're given 25, we have to calculate our molar mass. And then step 3 is to use our molar mass to figure out how many moles we were originally given. Okay? So let's keep going. Now we know that we were given 3.12 moles. But what's our ratio in moles of ammonium hydroxide? Ammonium nitrate. What is our ratio in moles of ammonium nitrate to water? Okay, well, we can use our coefficients up here. So our ratio is going to be 2 moles of water to every 1 mole of ammonium nitrate. Again, gathered from our coefficients, 2 and 1. So this is our ratio. Now, using our ratio, we can figure out how many moles of water we actually have, okay? So we actually have up here 0.312 moles of NH4NO3. We know this because the problem says we were only given 25 grams of it, and 25 grams equals 0.312 moles. So we've got 0.312 moles of NH4NO3. We use our ratio, 2 moles of water for every 1 mole of NH4NO3. So essentially multiplying by 2. So we end up with 0.628 moles of water. So now we know that if we are given 25 grams of ammonium nitrate, we will end up with 0.628 moles of water. But the problem is asking for the mass of water. So we have to do one more conversion step, okay? We need to figure out the total molar mass of water. So, okay, we do 2 hydrogens times 1.01 grams equals 2.02, and 1 oxygen times 16 grams equals 16 grams. So our total molar mass of water is going to be 18.02 grams. Okay, so our molar mass of water is 18.02 grams. We know we have 0.628. We can do one last conversion. 0.628 moles of water times 18.02 grams per mole. And that is going to give us 11.2 grams. And that is going to be our final answer. Okay, so to recap, you have to get the chemical equation. You convert from mass to moles. You figure out how many moles you have. You calculate your ratio of the 2 elements that you're working with, or molecules or formula units. Then you figure out how many moles of your desired element you have. And then you calculate the grams. Okay? Now, on page 363 of your book, I will write this down. Page 363. There is a chart that goes and a step-by-step in stoichiometric calculations that will help you, okay? So, step 1 is write a balanced equation. Write a balanced equation. Make sure it's balanced. If it's not balanced, all of your ratios are going to be off, okay? Step 2 is determine the moles of the given substance. Sometimes you will be given to it in moles. Sometimes you'll have to calculate it from the mass. Step 3 is determine the moles of the unknown substance. And then step 4 is convert from moles to mass. Okay? So when you break it down, you just have equation, moles of the given substance, convert to, use your equation ratios to figure out the moles of the unknown substance, and then just convert back to mass. Okay? So good luck. These videos should give you all the tools that you need to answer all of your JunoPod for today. Please call or text if you have any issues, okay? Do your best. I believe in you. You guys rock. See you guys later.